Okay, as mentioned, we're going to transition to this would be a brief video on the tenets of the Rubin causal model, sort of contrast, and slightly contrast to the stuff from Campbell in the previous video. Really sort of reading a series of papers, fairly recent papers, about these two sort of traditions of understanding causal inference. And one thing that struck me last night, and one thing that struck me, is that neither one of them really precludes the other. There are the fundamental differences between them at the end of the day are about procedures in quasi-experimental design in observational studies. So observational studies that don't have that fundamental characteristic of random assignment to control and treatment groups. I think I've mentioned that Campbell is no longer around. Rubin's still very, very active. I don't think these two would disagree at all about what we've said already relative to random assignment and the true experiment. A random control trial with a large and representative group of subjects. This is the gold standard in both the Rubin causal model and the Campbell causal model. These two models begin to diverge in procedure as you move to the observational study. And again, the charge, and this is very important in both respects, to try to fashion observational studies so that they resemble as closely as possible the control that results from random assignment relative to confounding variables. So we do a little sort of continuation of where we finished last time. This is the Campbell causal model tradition. And sort of describe what goes on in the analysis. So we have down here partisan choice, and this would be Obama versus 2012, 2008. 2008, Obama versus McCain, and this is the ultimate dependent variable, Y, in an observational sort of / causal analysis. The questions being, what causes some people to choose the Republican candidate? In 2008, that was John McCain. Or what causes other people to choose the Democratic candidate? This was now president, then candidate Obama. And we talked about partisanship and the issues and likability, sort of three variables that come together to determine and cause people to vote one way or the other. And just sort of at the very end of the term, not the very end, but coming days we'll talk about a technique called multiple regression. It's really easy. It's about straight lines. And you've already seen an example of multiple regression, not executed, but just illustrated from the example where I'm trying to define the term spuriousness of a relationship. And I talked about fire trucks, the number of fire trucks responding to fires, and the resulting dollar damage. Leaving out a variable, the important variable left out, was the size of the fire. And I kind of illustrated on the board, drawing scatter points in straight lines, what happens if you isolate on just 5 alarm fires of a similar size, and then ask the question, what does the relationship look like between the number of fire trucks responding across the data to the dollar damage done within only 5 alarm fires, or with only 4 alarm fires, similarly sized fires. That's what goes on in the Campbell causal model tradition in terms of analytics after you've given up on random assignment. So you don't have random assignment, so what do you want to do? I want to know if issues matter, and I want to know if issues matter after, quote, controlling, unquote, for other potential influences that might be related to issues. In the same way, size of the fire and number of fire trucks are related. I want to know, are these related, and if I hold one of them constant, and examine the relationship between one of them and vote choice across the individual eye. Hold one of these constant and let the others vary and see if there's still a relationship or if it washes out, or in the context of the fire truck, changes direction, goes up or down. So, in other words, so we've got partisanship here measured, let's say on a 3-point ordinal scale, Democrat, Independent, Republican. So I'm going to hold it constant at Republican. Hold it constant at Republican, then vary issues and likability and see if they still influence vote choice. That technique is sort of the foundation of what's known as multiple regression. It's a very common technique to use to make sort of iffy all causal inferences are iffy in the absence of random assignment to treatment control group. So we're just doing what we can here, holding these constant and individually and let the others vary and see if it works, as derived from the tradition of Campbell and company and their causal inference tradition. Now I'm going to get rid of it here. Rubin's different at the end. It's not different on the question of random assignment to treatment and control groups as being the absolute gold standard key to control for potentially confounding variables outside your X and your Y. They both agree. Campbell and Rubin are on that same, they're on that same train. They're talking about the differences arise in sort of the conceptual treatment that Rubin adopts relative to the quasi-experimental design, that is the one that tries to be as much like random control trial as possible and yet doesn't involve random assignment. This is where they differ, and so too do the analytic techniques. Now I'm spending less time on Rubin, not because I'm less convinced that this strategy I'm about to describe is preferable to the one that I just talked about. Not because of that, but because it's more common in our department, and this course really is not mine. It belongs to everyone. Some of you will actually use some of this if you do with a quantitatively oriented member of our department, not a master's thesis, but an honors thesis or a Croft thesis or whatever, and you're not going to run into many people who know anything in our department much about the Rubin causal model, more prominent in departments of statistics, certainly, because Rubin himself, obviously a statistician, Campbell a social scientist, both of them social scientists, but this is more formal. So Rubin talks about potential outcomes. This is sort of the basis of the conceptual difference between Rubin and Campbell. Rubin's talking about potential outcomes that are never realized. And this is actually true in the true experiment as well, but certainly in observational studies. So you've got an X that can take on only two values. We call it the treatment, right? Your treatment, if it's one, could be just a pill, okay? Let's make this a medical study. And so going back, we have all these data about whether somebody's taken an aspirin or not in advance or after the onset of a headache. And score those who took the observations that were people who took an aspirin as 1 and those who didn't as 0, or a couple of aspirin, or Advil, could be anything you want. And in the Rubin causal model, he focuses on the fact that there are two possible outcomes, and one of them for each individual in the study is never observed. So somebody either took an aspirin or they didn't take an aspirin, and for those who didn't take an aspirin, there's always out there and must be considered the potential outcome of what would have happened had they taken an aspirin. And the reverse then becomes true too for all of those in the group who took an aspirin. One in causal analysis needs to ponder the question of what would those individuals have experienced relative, let's say Y here is the severity of a headache. What would they have experienced had they actually taken one? When you set the problem up this way, it begins to lead in a different direction in terms of analyzing data, begins to head in a different direction, and points to some, in really deeply in theory, it points to some of the problems that are associated with the Campbell tradition of just running a multiple regression that includes control variables for those things that you think might be confounding. I mentioned I'm a fan in the Campbell tradition of models with very few variables, so very few x's. So issues was an x, partisanship was an x, likability was an x. I didn't have gender in there. I didn't have race. I didn't have any number of demographics that probably are in fact related to vote choice. I made it really simple, and the reason is because the technique, multiple regression, really has limitations in terms of causal inference. It has serious limitations as you move away from, say, 2 or 3 explanations, potentially confounding factors, and go to 5, 6, and you see sometimes in the literature, political science literature, a dozen, 2 dozen control variables, so-called control variables in a multiple regression. Not uncommon. That's really problematic. And in the Rubin causal model, the focus is on matching individuals in the groups so that they are similar on all of the variables that you could think of that might be potentially confounding. There are limitations, of course. You have to have a lot of data to do. Actually, you have to have a lot of data to do multiple regression, and you have to have a lot of data to use matching techniques as well. Let me sort of explain matching a little bit, and again, then we're moving on because moving on in the Campbell tradition because that is more common inside our department. So people are interested in the value of a college education, understandably, and they're interested in variables like college choice. They're interested in, for example, what is the lifelong income result of deciding to go to a private college versus a public college or university. So that could be your X, right? So 0 could be public and 1 is private, and so you get the treatment then as the private college. Then you're going to measure lifelong incomes or net worth or whatever you want to do as your Y, and you want to make a causal inference. So did the value of the extra cost of the private education actually have a causal effect on the person's income and earning power over time? The problem with that is you don't get to randomly assign to the private university and the public university the subjects. It is not an experimental design. You want to make it as experimental as possible. In the Campbell tradition, you would run multiple regression and control for attributes of individuals that might be related to both those things, income on the one hand and college choice on the other. And you'll be really limited, or you should be very limited, in your selection of control variables because there are problems that crop up if you don't. Statistical and too far down the line for this course. And in the Rubin causal tradition, one would try to match people inside these categories, 0 and 1, who are really similar on various background variables like the wealth of the parents, things that would have played a role in the selection by the student of a private university or a public university. Those attributes of the student and their background would be included, and those who had very similar backgrounds would be grouped together. The idea is to gain control over assignment to the two conditions. You want to understand the selection process here. The selection process that would lead people to choose private versus public college, and in a sense, model it or take an account of it. If you have enough data in an observational study like this, matching is a very powerful way to control for the myriad number of variables that might lead you astray because the selection process is not random here as per an experimental design. It's explicitly non-random, sort of trying to model that and matching people together so that you examine the choices inside, in a sense, subgroups of the treatment and control group. Subgroups who are very similar, who came from, who are of the same race, same similar background in terms of parental resources, and so forth. It may sound a little bit complicated. There's an R package written by Gary King, keeps popping up. Gary King and colleagues at Harvard. It's called CEM, for coarsened exact matching, and so easy to implement in R that in doing observational work, anytime I'm doing it, I'm using it these days, and it's kind of odd that I'm not going to teach it, and nearly to the degree that I will teach the Campbell tradition. But once more, it's not, of course, it's not about me. I'll probably illustrate this if we have time in class, and maybe illustrate a couple of differences in the two approaches, but this would be toward the end of the term. The CEM package in R is, and Gary and company write this in the paper where they introduced it, it's easy to understand as a histogram. So in fact they say if you can understand a histogram, and all of you have already created histograms, if you can understand a histogram, then you can understand the CEM package, and of course in exact matching. Exact matching is one of 4 I can think of techniques to do matching, grouping people inside what we would call otherwise control and treatment groups, grouping people together who are very similar, and seeing if the treatment distinguishes any sort of income difference later on with them. We're done with causal inference, and are going to, so remember the introduction to inference. Now we're going to flash over that. We're going to move to what was then on your right, my left, which is statistical inference, the feature of the next probably 2, maybe 2 1/4 short videos. The frequentist tradition, the Bayesian tradition, much more focus on the frequentist tradition because, again, that's the more dominant view in our department that's embraced by quantitative types, and so then we move on.